So the last class, we learned about equations that had one step and multi-steps. We learned how to move things from one side to the other, collect like terms. We learned how if there was a bracket, we have to distribute it to get rid of the brackets. Now we're gonna add a little bit more to the mix, and it's gonna be fractions. And I know some of you guys are not fond of fractions, but I do have almost like a recipe to follow to make these questions much easier. So let's take a look at the worked out example over here. I have a little box that says important steps, and if you wanted, you could go ahead and write them. I will just verbally say it, and I'll just point out some stuff, but you can feel free to take your own notes. So the question is 1 over 3x plus 1 over 5 is equal to 1 over 5x minus 1. You can see that the very first step is they found this number 15 and they're multiplying it to every single term inside in the entire equation. Does anyone know where they got the 15 from? Does it? Lowest common, yeah. Sometimes it's called lowest common multiple, lowest common denominator. Basically, what you do is when you have a bunch of equations in your fractions in your equation, you look at all of the denominators and you try to figure out what is the lowest common denominator. And that is the number that you're going to use to multiply every single fraction with. And the reason we do that is because what happens is all of the fractions magically disappear and you're left with a beautiful equation with no crazy numbers, and it looks exactly like what we were doing yesterday. So in the next step, you can see that they multiplied the 15 in every single term, including the last term, which is the constant. So you can't miss any term at all. Yeah, come on down. Once you do all the fraction work, you end up with an equation that is free of fractions. And now this is exactly like what we did last time. You move your x's to one side, you move your numbers to the other side, you simplify, and then you solve. So that's basically the idea of what we're going to be doing today. We're going to do 2 examples and then another 5 examples where you're going to work, and then we'll take it up. And then you can continue the rest of the work. So let's look at question A. So for question A, what I like to do, just like before, is I like to rearrange my equations such that all of the fractions are in front of the variable. Desi? Thank you. So this is going to be 1 over, just going to change that to that, 1 over 3x minus 3 over 2x is equal to 1 over 6 minus, if you wanted, you could change that into a fraction of a 1 over 1. You don't have to. Hopefully this step is not new to you guys, because I was doing that when we were doing distributive. I would sort of rewrite all the numbers like x over 3 to make it 1 over 3x, 3x over 2 to be 3 over 2x. Okay, now what we're going to do is we're going to look at all of the denominators. We have a 3, we have a 2, we have a 6, and we have a 1. What would be the lowest common multiple, lowest common denominator, or as what I'm going to call it from now on, the magic number, because it just makes it a little bit more fun in this question? Banujan? It would be the number 6, yeah. How did you figure that out, Banujan? So I know it is a little bit hard to explain. You know how I think about it? I visualize the 3 times multiplication table, the 2 times multiplication table, and the 6 times multiplication table. And I ask myself, what is common in all of those multiplication tables that is also as low as possible? So if you actually have your table in front of you, you just go down 2, 3, and 6, and you're going to notice 6 can be found in every single table, and it's the lowest common number between all of them. All right, so now what are we going to do with that 6? We are going to go ahead and multiply it to every term. There are a bunch of different ways you can do this. I will show you one way. So I'm going to just write 6 times, 6 times, 6 times, 6 times. And this just reminds me that I'm multiplying 6 with every single term. Another way is you could have just put brackets around the whole thing and a 6, and that also would work. But I find writing it in front of each term really helps you not forget about any number. Okay, now it's fraction work, you guys. We're going to be multiplying these two numbers together, the coefficients. So 6 times 1 is 6, and 6 divided by 3 is 2. Good. So this is going to become a 2x. Now we're going to go ahead and multiply this. So this is like saying 6 times -3 is -18. -18 divided by 2 is -9x. Okay, on to the next one. 6 times 1 is 6. So all I'm doing is I'm multiplying the numerator with the magic number, and then I'm dividing it with whatever the denominator was. So 6 times 1 is 6, and 6 divided by 6 is 1. And for this one, we have 6 times -1 is -6. -6 divided by 1 is still going to be -6x. So we have 2x minus 9x is equal to 1 minus 6x. Does this look familiar to what we were doing last class? It does, right? So what's our next step? What do we have to do? Yoda? Yeah, you can clean up each side. So 2x minus 9x would give me -7x. Whoops. And I can't really add 1 minus 6x because those are not like terms. Now, what am I trying to do here? What should I be gathering together? Yeah, so what do I have to move? Yeah, I'm just going to move the 6x to this side. So the -7x will stay here. When I move the -6x over, it's going to become +6x. And that's going to be equal to 1. Does this make sense so far? Am I allowed to add -7 plus 6 in this question? Yeah, because they're like terms. So that's going to give me -1x is equal to 1. And I want an answer where x is all by itself. So if I want to get rid of the -1, what do I have to do? Nope, because it's multiplied to the x. The opposite of multiplication is divide. So I'm going to divide both sides by -1. -1 divided by -1 is just 1x. 1 divided by -1 is -1. And so our final answer is x is equal to -1. Now, example B, I think, is a little bit more tricky. So before we get to example B, can we try a couple of questions on handout A? So just turn to the back. Let's do a couple of those where we're still sticking with the easy questions, and then we'll come back and do an example, the second example. Okay, so question number 1, we have 2/5f plus 3 is equal to 2/3. This question is already written really well, but I just need a little bit more space. So I'm going to go ahead and write it out again. You don't need to do this. We have 2/5f plus 3 is equal to 2/3. I am going to look at the denominators, and I'm going to notice that the denominators are 5 and 3. So if I'm trying to figure out the lowest common multiple, what do you think it would be in this question? Peyton? Yeah, it would be a 15. Because again, if you look through the multiplication tables of 5 and 3, the common number between both of them is 15, and that's the first one that you find. So now what we're going to do is we're going to multiply that number to every single term inside of this equation. I'm just going to move this over a little bit. There we go. So we're going to have 15 times this fraction, 15 times that constant, and 15 times that fraction. What is the point of me doing this? Well, when I multiply by the magic number, it helps every fraction disappear. So you could do this fraction work on the side, but I really want the final answer in your next response. So 15 times 2 is what? 30. And 30 divided by 5 is? So this is going to result in a 6x. Does that make sense? We basically did 15 times 2, which is 30, and then 30 divided by 5, which gives you 6. That makes sense? Okay. What is 15 times 3? Good. No F there. And the next one, again, we're doing fraction work. So we're going to go 15 times 2 is 30, and 30 divided by 3 is 10. And so this gives you 10. You could also cross reduce. So for example, you could go to the side and you could say, okay, we have 15 times 2 over 3. I'm going to reduce this to a 1 and a 5, and then 5 times 2 is 10. However you want to solve the fraction, it's up to you. You just grab a sheet of paper and try to figure out what it would be. Okay, now the question is super easy. We're going to keep our f's on one side and the numbers on the other. So we're going to have 6f is equal to, what would it be equal to? 10 minus 45, good. 6f is equal to, what's 10 minus 45? Negative 35. To get rid of the 6, I need to divide both sides by 6. I'm just going to move this up a little bit. So 6f is equal to negative 35 divided by 6 divided by 6. And f, can we reduce 35 and 6? No. So our final answer is just going to be negative 35 divided by 6. And actually, I have the solutions on the bottom of the page. So we're just going to check along as we go. So that answer is correct. Was that an okay example? Okay, again, if you didn't get the first two, let's see if the next one works. I want to do at least the first 5 with you guys. So maybe we'll do the second one together. And then the next you can try it on your own. Okay, so once again, this question is written really nicely. Every fraction is alone. We have 1 over 7x minus 1 is equal to 9 over 7. I take a look at my denominators, and anytime my denominators are the same, I get really happy because that makes the question just so much easier. We have a 7 and a 7, which means the lowest common multiple is a 7. If they're the same number, that's what it's going to be. We are going to go ahead and multiply every single term in this by 7. So 7 times 1 over 7x, 7 times negative 1, and 7 times 9 over 7. So you take that magic number, which is your lowest common multiple, and you multiply it to every single term in your equation. Okay, so what is 7 times 1 over 7? Yeah, it's just going to be 1x, because 7 times 1 is this times this is 7, and 7 divided by 7 is just a 1, so you get a 1x, but you don't need to write the 1. What is 7 times negative 1? Negative 7. And look, the next one is 7 times 9 over 7. If you cross reduce those, you're left with just the number 9, which is basically what you get over here. So we're going to have, actually use this. We're going to have x minus 7 is equal to 9. I'm going to move the negative 7 over to the other side. So I'm going to get 9 plus 7. And then my final answer is just going to be x equals 16. Yep. We're okay with this? Okay, let's keep going. Question number 3. Yeah, question number 3. So question number 3 has numbers that are a little bit larger, it seems, but that's okay. So we have, I'm going to write it again. So we have 5, 5 over 16 is equal to 11 over 16 minus 1 over 4x. Looking at the denominators of all of them, nothing is working. Everything is broken. Why? Okay, so I'm just going to highlight the denominators. We have a 16, and a 4. So what do you think is the lowest common multiple between 16, 16, and 4? Tezzy? It's going to be a 16. Good. So that means we're going to be multiplying every single one of these fractions and terms with 16. Okay, now look what happens. 16 times 5 over 16. I'm just going to multiply these two numbers on the side over there. You don't even need to multiply 16 times 5 or anything like that. You can just cross reduce. The two 16s will cancel out, and all you're left with is the number 5. How about 16 times 11 over 16? So 16 times 11 over 16, the 16s will cross out, and all you're left with is 11. And then for the next one, we have 16 times negative 1 over 4. You could cross reduce this, or you could just multiply out. In either case, you should have gotten a, what'd you guys get? For 16 times negative 1 over 4. Negative 4x. Good. Okay, you guys, I think this is our first example where the x is on the other side. So that's not a big deal. I'm going to take my negative 4x and move it to the other side. It's going to become positive 4x. I'm going to keep the 11 here. I'm going to move the positive 5 over to the other side. It's going to become negative 5. 4x is going to equal to 6 because 11 take away 5 is 6. Divide both sides. X is going to equal 2. We can't get a whole number, so it's just going to be a 3 over 2. Everyone okay with this? Okay, go ahead and try question 4. Dishan? You have to the 4x positive. You don't have to. You could just move the 11 over. That's fine as well. Tishan, try question the next one. Hey. Yeah, of course. So question number 4 was negative 1 over 15. Go ahead and try question number 5. I will put the answer up as well. And then I will tell you what we're doing next and why we're just going to pause. So for this question, we have 7 over 6 plus 8x is equal to 13 over 6. The lowest common multiple is going to be a 6. So we're going to have 7. Okay, so we have 7 plus 48x is equal to 13, and 48x is equal to 13 minus 7. 48x is equal to 6. By 48, divide this side by 48. So x would be equal to 1/8. If you finish question 5, did you guys get 1/8 for that? Okay, I'm not going to tell you. I'm going to pause here. I just want to tell you why. This lesson is actually a 2-part lesson, so we're going to continue this tomorrow's class. In tomorrow's class, we're going to be working on question B, and we're going to do some of the harder examples. So let me tell you what your homework is going to be for this first part, and then we'll continue this again tomorrow. We have already done questions 1, 2, 3, 4, and 5. Those are already done. For homework, please circle 6, 7, 8, 9, and 10. So you're going to try 6, 7, 8, 9, and 10. Don't do questions 11 and 12. That will be for tomorrow's lesson because they have the harder fractions, which we're going to discuss tomorrow. And also, you guys are going to check out the textbook questions at the bottom, page 361, numbers 19 to 40, just the even ones. You should be able to do those because those are more according to what we did today. So that's part 1 of equations with fractions. Tomorrow we will continue part 2 with the slightly harder questions.